My name is Jaanus Hallik. I'm working in university in Tallinn, Technical University in Tallinn, and working in the research group for near zero energy buildings. And today I will talk about the trends in building and ductwork airtightness in Estonia. And I'm presenting myself, but the work has been gathered by also two of my colleagues, Alo Mikala from the section of HVAC and from Professor of Building Physics, Targo Kalamäes. So a little bit about the background in Estonia. The first requirements about the airtightness of the building envelope was first introduced in 1995 with the first like design criteria for the building envelope, and it was like suggestion of the criteria that the entire building envelope on average should be below 3 cubic meters of airflow per hour per square meter of the building envelope area at the 50 Pascal pressure difference. Later in 2008, when the first energy performance calculation and certification scheme emerged, a general suggestion of the targeted QA50 value was lowered to 1 cubic meter per square meter per hour. But still, it was just a suggestion. There was no like mandatory criteria to achieve this during the building process. There have been several studies related to the building envelope airtightness and its development in current building stock in Estonia, but it's mainly dealing with the residential buildings where the indoor climate and also the building physics and the moisture problems inside the structures are really critical, are really important in our climate. There are no detailed studies on airtightness of the ductwork related to the energy consumption or indoor air quality in Estonia, but we have a lot of like smaller studies related to the ventilation system renovation in old apartment buildings, which all point to systematic problems with old shafts and ductworks, and usually this means that the airflows are unbalanced, the system is quite noisy, and the airflow rates are reduced in operation compared to the design documentation. So at first, a little bit about the building envelope airtightness. The indicator, what we measure here and what is targeted is building envelope air leakage rate. It's air permeability at the 50 Pascal pressure difference Q50 measured according to the ISO 9972 through the blower door testing. So currently, the target requirements during the energy performance calculation procedure is it's like different target you can choose. At first, it's possible that the engineer who is doing the energy calculations, they choose conservative base value from the tabulated values from the legislation, and they can use for detached houses this QA50 value of 4 for new buildings or major renovations, or 6 for minor or no renovation scenarios. And for all other buildings, meaning apartment buildings, non-residential buildings, hospitals, etc., the values are 2.5 and 4, depending on if it's new build or if it's just a minor renovation or just an existing building which needs the energy calculation. These are quite conservative value in comparison to the energy performance calculation targets in Estonia, which are quite hard to meet. So the legislation shows that you can use a good target value with QA50 of 1.5 cubic meters per square meter per hour to make the energy calculations in the design phase of the building. And after that, if the building is finished and you are applying for the use permit, you have to do the testing. This is mandatory. For the previous tabulated values, the testing is not mandatory. And currently, we also have a third possibility to use during the energy performance calculation, which is pointed out also in this bulletin Norwell was talking about. It's a specific declared air leakage rate where one building company or prefabricated building manufacturer uses the same technology and has proved with at least 5 buildings that they are meeting a consistent low level of air tightness, but it's ineffective from the 1st of June this year, because the legislation is changing, and this criteria is then not anymore possible. So it was based on Finnish design criteria that we have the mean value for this type of building, and then we have the variance, and then we just make the statistical calculation to show that if we have 75% of buildings with a confidence interval of 84% in this limit, then we can use this value. But this is not possible in June and onwards. So I'm not going to be talking about this more. What about the testing? No national guidelines. So the measurement is strictly according to the ISO 9972. There is no national qualification scheme for airtightness testers, but the testing equipment has to fulfill, of course, the calibration requirements, meaning that you have this pressure measurement unit and all the blower door fans and equipment measured within 2 or 3 years, depending on the system. You have to have calibrated system to give out official report of the air testing. There is not too much companies that are doing this. The university does this, another university does the testing. There are, I think, 3 to 4 very prominent testing companies that have very high-level engineers working there. And of course, builders have a little bit like their own testing units just to test the preliminary values on site, but for the final testing, it is usually needed that some of the more prominent companies or the university comes to test the final measurement. We don't have exact data, but the rough estimation is that around 30 to 35% of the new buildings and major renovations are tested in Estonia, and there is no national official database of testing results. However, in the university, we try to maintain a partial database, meaning that we put all our own measurements into the database, and each year or in each second year, we ask for the results from all the main companies that they should share with us, so we can do some research on our side and maybe point out some things that has to be changed or has to be considered during the construction process in Estonia. So a little bit about the development of airtightness in Estonia. You can see one a screenshot from research we had. I will later show where it's published. On the left-hand side, we have the detached buildings. On the right-hand side, we have apartment buildings, and you see the year of construction, and on the horizontal axis and air leakage rate, the QA50 at the y-axis. And you can see that and the last red line indicates this year when the energy performance legislation and criteria was officially taken into consideration, or it went into effect. So you can see the airtightness of the buildings has been getting very, very good after that for both groups. And if we look at the different structure types, like log wood building, lightweight timber frame, prefabricated concrete panels, or small concrete blocks, or these aerated concrete blocks, then within each group, the air tightness or the air permeability value at 50 Pascal pressure difference has been lowered significantly. So for the log wood, it's come down from 13 to 2.3, with lightweight timber from 5 to 1.2. For prefab concrete panel from 6.2 to 1.2, and small blocks, it's a little bit similar. The only type of structure was brick wall, which hasn't seen such a huge reduction. And of course, another thing is that the variability of the measurements has reduced significantly. So on the bottom right-hand side, this left part is the buildings built before 2010, meaning these were the buildings that didn't have to calculate and prove the energy efficiency. And on the right-hand side, it's all the measurements we have in the database that are built after that date. And you can see the variability of the measurements have diminished significantly for both groups, apartment buildings and detached buildings. So apartment buildings are the left columns and the detached buildings right columns. And from there, you can see that old apartment buildings were significantly more airtight compared to old detached houses. However, if you look at the scale, then it's around 5 to 10 and even more for the detached buildings. So the airtightness level was not great considering the cold climate we have here. In new buildings, we also tested some key factors that are tested in other countries to see if we have those factors affecting the airtightness. No difference between apartment buildings and detached houses are registered anymore. So if it's done correctly, then it's almost the same. The number of floors or compactness of the building form doesn't have a significant effect based on the database. The energy performance class A buildings are a little bit more airtight, meaning that it's below 1. The average value is 0.6 compared to the 1.2 of B and C class buildings. And a very specific thing in Estonia, the detached houses are a lot of times they are built from this lightweight keramzit block elements. And this has shown almost twice the air leakages compared to these small concrete blocks. So from this type of buildings, we usually expect a lot of air leakages between this lightweight keramzit granules. And of course, building prefab companies with systematic measurement routine have significantly lower variability of air leakage rate and very low airtightness values, but airtightness is significantly improved only with timber structure. So no other like prefabrication elements have the same effect. But these lightweight timber buildings are really, really good, and several companies have the average or median values below 0.6 or 0.5. So I will not go into detail in this slide, but you can see this publication we had a few years ago where we tried to do overall statistics on different age groups and different construction types on detached and apartment buildings in Estonia to see what is the spread of each group and what can be estimated for a building when you're doing energy performance calculation for specific purposes. So if you have interest in this, you can go and check this out. And about the ductwork airtightness, as I mentioned, it's not really studied a lot in Estonia. As of the airtightness indicator, we have the maximum permissible leakage airflow per casing surface area, Fmax, measured according to the standard 12599. And current target requirements are so that the airtightness class of ventilation ductwork should be at least 4 with previous name of B. And recommended ducts and components should be of class B, C, or better. But the ductwork airtightness testing is not mandatory and depends on client's requirements defined in the contract and the project. So basically, the designer selects components, proposes a level in the contract, and then it's agreement from the client. And then if this is like for some specific buildings, for hospitals, for clean rooms, for like large cold storage houses, there's a specific more strict level agreed on the contract. But usually It's just default, and usually 10 to 15% of new houses are measuring the air tightness of the ductwork. And as of now, the air tightness of the ventilation duct, there is not directly an input for the building energy calculations and the energy performance certification. So it's very like not very hard criteria, unfortunately, for this part. So from my side, I think I have finished my 15 minutes. Thank you for your attention. And if you have any questions, then I'm happy to answer.